So let's take a look at this first example. Just take a moment to read over it and we'll discuss it. So what you notice here is that we actually have a diagram that involves arcs of a circle. Yeah, I'll go through it very carefully. Don't worry, I'm gonna work it out with you guys. So the first thing that you notice that there is arc of a circle. The second thing you notice, as mentioned in the chat, is that there is symmetry in the question, so you could cut it in half. Actually, there's two lines of symmetry. There's one this way as well. Finally, you need to kind of piece together all of that information and eventually find a right angle triangle. So what I'm going to do is divide the figure up into 1/4, because half of the figure is symmetry one way, and then there's the other half the other way. So let's take a look here. So if I cut it along this line, and then I cut it along this line, what you really can do is I'll draw a rectangle around it. Draw a rectangle like this. And this is the rectangle that we're going to use to solve the question. You can use any side of the figure. So like if you're like, well, I don't want to use that one, could I use this one over here? It's all the same. The thing is that we need to go actually to the end of the point here. Now, why would this one here is not good enough. This one here is better. Why would this one be better, the one that I drew this way? What's better about this line versus this line? Why is the left one better? Let me know in the chat. Why is the left one better? Why is this one better? Yeah, there's a couple of reasonings there. One of them indeed is that we have this measurement available. And there's the other reason that this is the center of a circle. So when you have the center of a circle, yes, Denny, yes. When you have the center of a circle, it's very valuable to us. So that goes back to our discussion last Friday. So we can take this information here. I'll use this rectangle because I already started drawing here anyway. But you could have used any quarter of the picture that you wanted. So what we're going to do now is piece together the answer. Oh, it doesn't matter, Rem. You could use the right side. You could use the right side. You could use any four of these figures, any four of these rectangles. I just didn't want to use these. I kind of, my mind went over here. I just started writing stuff over here instead. So that's why I went there. No particular motivation for that. And now we can draw a triangle, yeah. So let's do the following. Before we start drawing a triangle, I'm gonna just take this box here, and I'm gonna just screenshot it. Yeah, we're well on our way to succeeding this for this question. So just gonna take that figure and just drop it in. So let's take this diagram here. I need to do a little bit of care. Take a little bit of care here. So if you don't mind, when I'm editing the video later, I'll cut out all this time where I'm kind of cleaning it up a little bit. I just want a nice clean diagram. So let's talk about where the triangle is. I'll draw the triangle in red. Remember that the radius of a circle, which is this red ray here, all of these radii are part of that circle, but the most valuable ones to us are this one. There's one right here. And corner to corner, yeah, that one right there. So this is a radius. This is a radius. I'll double tick it. So this, I'll just color it in red. So that's 2.59. The units are in inches. So if I can't squeeze the units inches, you understand that this is also in inches. I'll try my best to color code it. Here's our right angle triangle. Let's draw that in purple. So there's the right angle triangle. And we're going to put some information on that diagram in a second. Got to move it over a little bit. Sorry, people. Right. So What else do we know? Well, what's this length here? Anybody have that number? How do you get this height? Very good. Maha, you are a champ. So yes, that's right. Thank you, Ram. So everybody's like wondering, if I put 2.14 here, it's because I took the 4.28 and I divided by 2. Cool. We can also play the same game at the top or the bottom. So can someone compute this length for us? Let me know in the chat. What's this length here? Whoops. This thing just keeps on going. How much is that? Yes, 3.175. It's this number divided by 2. 3.175. So it looks like we've taken a question that's like, what the heck is going on here, and turned it into another question that's manageable. So I need to do one more thing, and then we can actually start answering the question. I'm going to label some stuff on this figure here. I'm going to call this length from here to here. I'm going to call that Z. And I'm going to call it from here to here. I'm just going to call it Y. One more thing, and I think we're ready to go. Sorry. Okay. I'm going to keep on going here. Let's write down some equations. Oh, you are a machine. You are a machine, Maha. I got to catch up to you. Don't worry. I'm going to catch up to you, okay? Because there's a few things I want to write down here. First, Z plus Y equals 3.175. Does that make sense? Straight up here, right? Z plus Y is 3.175. One more. Maha already answered this one, but I'm going to write it down here. Z squared plus 2.14 squared equals 2.59 squared. So that comes from the right angle triangle. So if you want to, as I do these, I can put little symbols. So let's give this one, let me see here, pink, okay? So I'll just put like a check mark here. So that comes from here. This one here, I'll put a little star. That comes from here. And finally, we need to find x eventually. Can anybody tell me a formula that connects x with the information on this figure? How does x relate to that figure? What do you think? I'd like a little formula that tells me how x connects to this diagram. I'll continue. I feel like there's a little bit of uncertainty here. Anyway, this is x. No problem. What's this? How much is that? It's y. Yeah. You have the formula there, Ram. That's good. I was gonna just say that x equals this. See, x equals y times 2. That's all. That's all I was really trying to say there. So x equals 2y. What I've done is put out enough formulas for us to solve this question. Now, it doesn't matter if you answer it this way. What matters, though, eventually, that you will calculate something related to each of these three formulas. So our strategy will be to do this first. Let's get z out of the way. And Maha already calculated that, but I'll just do some extra typing here to support people that might need to see steps there. I'll catch up to the conversation in a second, people. I'm just typing this now. So you get Z is 1.459 inches. Okay, so that's Z. So that's the first thing that you can do. And now over here, you can get Y. And you can definitely simplify this writing by using information that your friends are typing in the chat. But I'm just going to stick with what I have here. You can do this calculation that I'm doing is similar to what Maha is doing in the chat. So when you do this way, you get Y is 1.716. And finally, X equals 2 times 1.716. So then X equals 3.432. And there you have it. Tic-tac-toe. 1, 2, 3. 3 things to do. When you're looking back at this later, if you're like, well, what did he do first? The first thing I did was this, and then I did this, and then finally I tied it all together, and I did this. I know there are people in this audience that are like, I don't like all these variables. I just prefer to fill the figure in with numbers and just get it that way. And honestly, if that's your preference, you can most certainly do that. You don't have to write a single variable on this diagram. However, I find that when I get into a situation where there's a lot of information to communicate, I like to give it some labels. Now, just a hypothetical. Let's say this question was on an assignment, for example, not a test. On a test, I just want you to get the right answer and show me some work. But if it was on an assignment, if you just start filling in the diagram and don't really explain yourself, then it's not really presented well, and I do want to see something that's coherent, not just a figure being filled in. Because an assignment, you can always go back. An assignment, 1 second, Ram. An assignment, you can always go back and you can make it look better, just like you're writing an essay. So Ram had a question. See that in the chat there? Ram had a question. How to write the final answer to nearest eighth of an inch? So it's almost like you knew I was going to do this, Ram. I'm going to show you something that I'm working on. So here's a little video. Can you see my new screen here, the black background? Okay. So I'm going to make a little video and I'm going to throw it on YouTube probably tonight or tomorrow. Or sorry, not tonight or tomorrow. I'll put it on today. Don't worry. But I will explain your answer, Ram, right now. I will do that explanation right now, okay? But I'm just saying that for those that were asking me last time, can I put something up about the conversion? I've already done that. I'm gonna make this video and do an example 1/4 inch, and then I'm gonna do another example with 1/8 of an inch. Okay, so I need time to write that up. So I just was preparing it for that reason. But yeah, you want to do 1/8 of an inch? I'm totally down. So let's rock that. I don't know who asked me last time to put a video about that. Okay, Shalon. So if I don't see you in I don't care about YouTube video comments and whatever, but I want to see a comment from you saying, I watched the video, and I'm obviously joking. So okay, I don't care if you watch it. I just care that you understand. Okay, anyway, so but to answer Ram's question immediately, why don't we just do that quickly here? I don't mind at all. Perhaps it's a dress rehearsal for my more fancy presentation later. Let's do the following. Let's take a question in the metric system and do a conversion. So let's convert, and I'll just make something up. I don't know how well it's going to work out. I don't really care. I just care about the method. I don't care about how pretty the numbers are, because in real life, the numbers are not pretty. Convert 3.916 meters to feet and inches. Ram, I put 1/4 inch here. I know I put 1/4 inch here. Don't worry, Ram. I will do 1/8 of an inch as well, okay? I promise you. I'll do the same question with 1/8 of an inch. Or I'll change numbers so you get variety. So you people have calculators, and I am relying on you to help me out with this because my calculator is always non-existent when I teach. I want you to do the calculations. So first we need to make meters to feet. So 3.916. This is a little bit extra compared to your assignment, but it's good practice for you. Okay, most people know this conversion. If you don't know this conversion, you should know this conversion. You don't have to know it to 3 decimal places, but just humor me and do that, okay? So can someone multiply those two numbers, please? Anybody have that on their calculator? Thank you, Ram. So now we have the answer in feet. For those that are kind of wondering what is going on here, why am I doing this fraction thing, okay? Remember that when you want to convert from one unit to another, you can also write it, multiply by a fraction, because this fraction here is equal to 1. Denny, give me a chance, my friend. I'm trying to go slow here. You're a champ. Okay, so these meters will cancel. So that's the reason that we put the meters on the bottom. See this fraction here? This is often overlooked. The top is worth the same amount as the bottom. That's why this is actually equal to 1. And when you multiply by 1, if you multiply by 1, you don't break anything. So that's a little bit of unit conversion review. So yeah, these cancel and you got feet now. So now we got to talk about the feet. I want you to think about it like you're putting it in the bank. So at the very end here, here's my answer. And it's probably going to look exactly like Denny's soon. Right now, I know for sure it's 12 feet. 100% it's 12 feet. But I need to deal with the decimal part. And this is where this would help you for your assignment or whatever else I might ask you in class. So now I'm going to take 0.848 feet. And I'm going to multiply that by how many inches in a foot? Oh, okay, I got you, Denny. Totally cool. So what Denny did is totally cool. He went, or they went straight away to whatever they need to do into thing feet or inches directly. So in this case, we have 12 inches per 1 foot. I know I might be going slow for some people, but honestly, I wanna end this once and for all that you don't get worried about this conversion because it's so badly overlooked. Can someone multiply those, please? What is 0.848 times 12, please? Thank you. So now this 12 here is in the bank. This 10 here is in the bank. Put it in the bank, right? Do not touch it at all. It's 12 feet, 10, and something inches. So now we're dealing with the fraction part. This is the part that people have a little bit of uncertainty, and I'll help you deal with it right now. This is how I do it. This is how I do it, and it works really well. I can put inches here, and I'll just put inches, but you don't have to write the inches. Okay. What is the fraction, people? When it says quarter, when you say quarter, what fraction is that? What's the denominator? Yeah. Yeah, thank you. So the only Shalon's answer is what I want exactly, and the end of Denny's comment there. When you write a quarter, the denominator is 4. So here's the thought process, people. Focus very carefully. When I multiply by 1, is that okay? Can I multiply this by 1? Do I wreck it in any way? Do I break it? No, exactly. But 1 is not useful to you. You know what's useful to you? 4 over 4 is. Because 4 over 4 is still 1, but that denominator is 4. And this is the secret, people. This is how I do it, and it works every time. I take the 0.17 and I multiply by 4. Can someone multiply 0.17 by 4, please? We're almost home. We're almost home free, people. Let's do this. What's 0.17 times 4? Good. Final step. This is the final step, and you're all in the way, okay? This numerator, see this numerator here? Is it closer to 0, 1, 2, 3? Which is closest to? What is it closest to? 0, 1, 2. Oh, thank you. Thank you, Maha. Whoa, I just did something silly. It's quarter. And that, my friends, is the answer. Understood? That is how you convert to quarter inch. Tic-tac-toe all the way down. What do you think? I'll do 1/8 of an inch next, Ram. Don't worry. Let me know in the chat. Did you understand that? Did you like that? Did it make sense? What's going on there? Anybody? Yeah, greater than. Shalon, how is 0.68 closest to a quarter? It's not, Shalon. 0.68, I'm taking 0.68 and I'm rounding it to the nearest whole number. 0.68 is closest to 1. That's all I'm doing. Now to continue with Ram's question, because Ram's question, I can answer it very, very efficiently. I duplicate my slide. So I have the slide here. That's your answer. I'm going to do a new picture. Oh, now it's 1/8 of an inch. Okay. Instead of 4 over 4, no problem, people. We got this. We got this. It's 8 over 8. Put an 8 there. Put an 8 there. Put an 8 here. Put an 8 here. Yeah, what's 0.17 times 8? No, wait a second. Yeah, what's 0.17 times 8? Thank you. Sorry, I'm just typing this at the same time. That answers Ram's question. So whatever it is here, if it's 1/8 of an inch, you put 8 over 8. If it's 1/4 of an inch, you put 4 over 4. If it's 1/16 of an inch, you put 16 over 16. You're very welcome. I'm going to show you something now, everybody, and I don't mind posting it on Blackboard, but I do want you to do the work yourself anyway. Just, oh, you're very welcome, Ram. I'm going to go off screen. Yeah. So just give me a second. I'm going to get something from my computer. I'll be there shortly. I'm just on a different window. So this is my little baby. Whenever I write a program, it's like my little baby. What was the number that we used in the previous question? Let's take a look here. It was here, 3.916, right? Oh, sorry, I have to put 1/8 here. That's my bad. So 3.916, okay? So if I put here 3.916, watch what happens. Check it out. Who likes my little program? Who likes my spreadsheet? Thank you, Shalon. Well, whether or not you like it or not, who would like to have this spreadsheet? Who would want this spreadsheet? Anybody else? Or am I just going to email to Shalon only? Thank you, George. I'm just bugging you. Thank you, George. Yeah. How about I put this on Blackboard? I'll put this on Blackboard at some point today, and you can use it at your leisure. So yeah, all I did here was you're very welcome. What I did here was I just coded in Excel all the different fractions. So, I mean, we're not doing tool and die here. But if you were doing tool and die, you need to know things like 30 seconds or 64ths of an inch. Here, we're doing construction and construction related disciplines. So the most you'd probably go is 1/8 of an inch or maybe 1/16 of an inch if you're doing something really special. So for that reason, I will share this with you and you can use it to do your assignments. And when you're looking at those blueprints in the future that are in the metric system and you need to know how to do the imperial, there you go. Okay, so that's gone. And let's get back to business. I'd like to do another example with you before we get too far off track. Although it is good that Ram brought that up. It was a very valid question, and I appreciate that question because that's why we're ahead of the game. We can do a little bit of stuff like that and help you become stronger with your measurements. So let's take a look here. We have another blended curve question, and then we can do that. You're most welcome, Ram. It's a pleasure. So anyway, take a minute and just read over the question. Yeah, there's 2 circles here for sure. And we're going to talk about how you would approach this question in a second. The one thing is when you look at the diagram, keep in mind that the notes that I've given you, the diagrams were handwritten and then they were scanned. So they're not to scale, and if you try to do some of the constructions on them, it might not be the most perfectly straight line that I draw, and you'll understand what I mean in a second. So this is it's the unfortunate thing about trying to draw blueprints and then trying to scan them and then trying to use the digitized version to do something. But anyway, they are good questions, and definitely it would be nice to explore this one. So as mentioned in the conversation, indeed, there are 2 circles here. See, there's 2 arcs of a circle. There's an arc here in purple, and then there's an arc here in green. So let's thicken up the arc here. I'll do it in pink, actually. So we're trying to see how that works together. Over here, remember, that's the center of a circle. And as always, the center of the circle has been important. The center of a circle has been important for every question so far where there was a circle involved. So what we would like to do now is somehow incorporate the circle's centers and their radii ultimately to find the length at the bottom here, x. And the secret to this question really is, yes, the circles will be tangent. Earlier in the chapter, I mentioned that there were 7 patterns that you can use, or if you want to call them rules. So right now we're using this rule here, which is rule number 5. So it says here if you have a blended curve, which can be approximated, for example, with 2 circles being tangent. So if you extended the bottom circle, you see the circle continues there, and then the upper circle continues here. Then you can actually connect the 2 centers together, and that will be a straight line, and this will be a 90-degree angle. So that's what I was talking about last week as we touched on this type of more challenging concept with the Pythagorean theorem. But we go back here now, and we're going to apply that logic to this question. So I'm going to draw this with a toolbox because I feel it's going to take me forever to do it the other way. So anyway, so how's everybody doing today? How's everybody doing? Are you enjoying the lovely weather outside? Good, I'm glad. I mean lovely weather tongue in cheek here because, yeah, it's Friday. It could be blizzard outside, but you know what? It's a Friday, exactly. That's exactly what I say. I'm glad you feel the same way, people. But I don't know about you. I don't know where you are in the city, but it is windy where I am. I don't know who, is it windy in your area? Because there's furniture moving around on my balcony, and I'm kind of getting paranoid that something's gonna happen. Oh, you're very kind. Hey, I told you for Etobicoke. Okay, Ram, is it Etobicoke or Etobicoke? That's the worst joke. Sorry, that's really bad. I don't know. Every urban area in Toronto, there's always a letter missing. Like when you say like Toronto, we don't say the second T. Etobicoke, we don't say the K at the end. What's going on? What's going on? Are we just lazy in Toronto? Is that what it is? Or are we efficient? I think we're efficient. It's sunny on your side. Where the heck are you, Cancun? Jeez. All right. So anyway, I finished drawing the picture. I'll get back to business now, people. Wow. Well done. Well done, my friend. Okay, so in this case, we have two sectors of a circle, and this is a straight line because of that property. So if you're like, how do you know, sir, it doesn't go like that, like bent? It's not bent because it's the circle tangent theorem. Ultimately, we're trying to find x, and it's been tried, tested, and true with our course that you can draw a rectangle around it and deal with it. So I'm going to use the highlighter this time for the rectangle. So this yellow here is a rectangle that frames the figure beautifully. So let's talk about the dimensions of that rectangle. Can someone tell me what this length is here? I'm going to highlight it in blue because I cannot fit it on the diagram. And I don't want to give it a name. Can someone tell me what is that height there in this little corner here? How much is this? I need that height. Help me out. That is correct. Maha, in the chat, can you show a calculation on how you did that? That is correct, by the way. Very good. Perfect. So let's clarify. I should probably type this. Let me type this because this thing is way too slow for writing numbers. So this calculation here is 18 minus 13.8. So what Maha did was subtracted the two heights on the respective sides of the of this figure. So when you do that, you do get 4.2 meters. If you're wondering, where did the 18 come from? The 18 came from the left side and the right side difference. See, this here is 18. This overall height is 18. So then this overall height is 18, but 13.8 from 18 leaves you with 4.2. And ultimately, we are in the home stretch of things. So let's draw another line segment. Let's use green. How much is this length here in green? How much is that length there in green? Let me know in the chat. 28. Can you tell me how you got that? Beautiful. Beautiful work, people. That's 28 meters. Who thinks this question is easier than the previous one we did? Who thinks this one's easier than the previous one? Yeah, I think so too. I'm feeling you there. Totally agree. So let's draw that triangle there because we're almost in the home stretch, people, to do this question. So there's the right angle. This is x. This is 28. That's in meters. One more thing and we are ready to go. Rock and roll. Here we go. I'm going to get the pink out for this one, or magenta color. This plus this gives you this. So what is the number that goes here? What's the height of this triangle? Any takers? What do we got here? This one's dangerous. All right, it's a race to the finish. It's like the Olympics. Yes, 14.2. That's 14.2. So let's reason it out, because people are going to be looking at this later and scratching their head. This, I'll do it nice and thick here, okay? That much there, that's 4.2. And this is 10. It's 10. It's the radius of the other circle. So there you go. And we are ready to go. Let's do this. So we got here, is x the longest side on this triangle? Is x the longest side on this triangle? Nope. So we're going to do subtraction. I'm doing the shortcut this time. Last time I did it the long way. This time I'm taking the shortcut. I took the scenic route last time. And that, my friend, is the answer to the question. High five yourself, because that is what I wanted to achieve with you today. That is some fantastic work, everybody. So if you can do the questions up to 7, you are ready for this test, okay? You are ready for this test if you can do everything I've shown you up to here. This one here, up to 7, yeah. Question 8, and question 9 are a little bit nasty. However, I'm not going to take them up in class because they take a long time, and I need to cover 3D Pythagorean theorem with you today. Also, I want to give it as a challenge. I know there's people in this audience that can do these questions without my discussion. So these two questions, 8 and 9, I'll make a note of it so that it's crystal clear. Don't worry about this for test. Sounds good? Could I be any more clear? And this one here, I changed the color because it's a little bit irritating that it's in the way. Let's go with the light gray. It's kind of like when you're looking at those secret documents, if it's like one of those spy movies, and I'm like, this is classified. Okay? Don't worry, and don't worry. So we are in a position now where you could write the test. There's nothing else I need to teach you for the test. So what I'm going to do now is, I had 3 things to do with you today. We covered the first one, which is to take up the remaining questions from this section. And I also tossed in some extra unit conversions thanks to some good questions from the students. All right, welcome back. This is the second part of the lesson. We're going to work on the 3-dimensional Pythagorean theorem. This 3D theorem is not on your test, but that doesn't mean we're not going to cover it. So in this case, if you consider a box here, you can actually find the diagonal. So this D here, letter D here, is the diagonal of the box. It represents the largest distance, straight line distance, that you could draw within a rectangular box. Some of you may not have known that the Pythagorean theorem, it goes beyond 2 dimensions. It turns out, though, that the Pythagorean theorem can go for any number of dimensions. It can go for infinite dimensions. In terms of practicality, though, for everyday life, 3 dimensions is more than enough. Yeah, actually, if you do any type of physics or vectors, you end up observing the Pythagorean theorem in, for sure, 4, 5, 6 dimensions, depending on the context of what you're looking at. Anyway, in this case, I just wanted to show you the diagram here. So take a look. We want to find the length of the diagonal D of this box. So let's zoom really deep into this box here. So can you see that there's actually 2 right angle triangles? There's the red right angle triangle, which is kind of like on the floor. If this is a room, imagine this is a room, and then the bottom of the room, the floor is AB. Then we can draw a red right angle triangle, which is indicated right here. That's triangle number 1. And then we can actually draw a vertical triangle. It's still right angled. See that right angle right there? It's a vertical right angle triangle, and it has a height of C. Its other leg is H, and H is the hypotenuse of the red triangle. So they all kind of tie together. Ultimately, you're trying to find the length D. So what I'm trying to do here for you is prove, or derive, I should say, this equation. Deriving this equation, which tells you how long the diagonal will be in this box, or rectangular prism, is really quick with this picture. So I'll do the derivation. It should take me less than 2 minutes. I'll do it down here, okay? From the red triangle, we know that a squared plus b squared equals h squared. From the purple triangle, we have c squared plus h squared equals d squared. And there it is, my friends. What you can do is, you see h squared here? H squared is equal to a squared plus b squared. I'm going to replace this h squared with a squared plus b squared. And then you're in the home stretch. Let's write that backwards. And you can take a square root. So I'll take the square root of that right now and just dump it in there. And there you have it. That is the derivation for the three-dimensional Pythagorean theorem. So let's take this theorem here and apply it to maybe a few examples. I'll probably do 2 examples with you, maybe 3. And then after that, we can do some fun algebra questions toward the end of the chapter. So take a look here at question on page 24. It's a box. This block is 2 by 3 by 4 inches, respectively. And it wants you to find the distance diagonally opposite from A to B. So that's precisely the diagonal of the box. So we're trying to find that diagonal distance. That's D. So let's do it. Okay, well, question for you in the crowd there. ABC. ABC is 2, 3, and 4. But does it matter which one's which? Does A have to be 2, and then B has to be 3, and C has to be 4? What do you think? No. Very good. It doesn't matter what the ordering is. And this is what I was getting at with the Pythagorean theorem in the first place. I don't care how you label the triangle ABC or whatever. All I care about is that the longest length, which in this case is D, it's the diagonal, or in 2 dimensions, the hypotenuse, that's the one that has to go by itself. So in this case, we would have 2 squared plus 3 squared plus 4 squared. And can someone in the chat give me an answer for that, please? Let's go to 3 decimal places, because the question says that as well. 3 decimal places. I got 5.3 something. 5.3, 5.385. Thank you. Thank you. I was trying to do it in my head, because like I said, no calculator. So there you go. It's root 29, or 5.385 inches. So that pretty much irons out how you deal with the Pythagorean theorem in 3D for something easy. There are other questions in here that are not so easy. And I'm going to actually explore a couple of them. So let's take a look at question 30. This one's quick. What is the distance diagonally opposite corners of a cube? So it's a cube this time. So when you have a cube, that means that A, B, C are all the same, which in this case is 40 centimeters. So then you'd have B equals, all right, so that's going to be 4,800 square root. Thank you, Denny. Can you square root that, please? 2 decimal places. I'm going to look at the answer key for this one. Yeah, I got that on the answer key. How's everybody doing in the chat there? Let me know. How you guys doing? Feeling okay with this? Okay, perhaps I can show you how you apply it to something a bit more intense. How the heck do you do that? Let's take a look at this roof question. I love doing this question because it just proves a point that when you look at something like this, you get scared sometimes, and then hopefully the way that I teach it to you, it makes it a little bit easier. So we're trying to find information about this length here. We're trying to find the length of A to B. We're trying to find that length there. And as you can imagine, that length there is three-dimensional. It's a three-dimensional length. What I mean is that, sorry, you need 3 dimensions to compute it. Because A and B are not necessarily on top of each other. They're not in the same position in the 3 dimensions with respect to each other. So you need to calculate 3 separate distances to find the distance from A to B. So this roof here, we have A at the top of the roof, B is at the bottom of the roof, but also, if you look at it from above, you can see that A and B are not actually, like, if you were standing right here, A and B are not the same distance from you. I don't mean vertically, but I mean just from above, if you're looking, because this is a 30-foot width to the roof, and that span there is going to affect A and B. In other words, B is in front of A. Also, we have a third dimension to deal with. So I'm going to ask you 3 questions, and that'll help us solve this question in very easy fashion. So here's my 3 questions. Question 1, how far above B is A? According to that diagram, what do you think that is? What's the answer to that question? How far above B is A? Anybody have an answer on that? 10. Can someone else confirm? Anybody else agree with that? Anybody disagree with that? Hi, Malik. Okay. Yes. A is actually 10 feet above B because it's the height. It's right here. See, this height here is 10. This is a 10-foot height, and that carries all the way through the building, through the roof of the building. Here's the next question. How far to the right of A is B? A trickier one. Oh, one of your answers is right. So this is going to be very democratic, okay? People, who's voting for Malik and who's voting for Maha? Is it 30 or 20? Anybody else? Anybody else out there brave enough to do this? Because I'm getting a little nervous. Is it because it's Friday? All right. Anyway, the answer is indeed 20. It's good work. And don't worry, Malik. Your answer's on the way right now. So, oh, sorry. Let me explain the 20. Thank you for asking that. This is 40. And if you were to drop a vertical there, that's half of 40. So this is 20 right here. This is 20. And if you drop a vertical line to the bottom of the roof, that's 20 as well. Is that better? Cool. The roof is symmetrical in its cross sections. Okay, this is a tricky one now. Looking from above. You have to think about it as you're looking from above. How far behind B is A? Maha, did you get the final answer? Are you showing off your skills? All right. How far behind B is A? I'll assist you here by drawing a plan view. Are you familiar with what a plan view is? What's a plan view? What does it mean to have a plan view? Bird's eye. Thank you. So let's do a bird's eye view. And for those of you who like Tetris, because I love Tetris, that's the Tetris view of this building. Just kidding. It's not Tetris, okay? So if you look from above, A is over here. This is from above, and this is B. And remember, the observer I'm talking about is here. We're talking about if you're looking at the building, if you're standing right here, if you're X and you're looking at this building, you're looking that way. You can see that offset, there is an offset there, and that A is actually behind B. This is 30. So the conclusion is that, sorry, I'm trying to draw a 3 there. The conclusion is that this length here is 15. So 15 feet. And there you have it, my friends. We got this. 15 feet. Congratulations, you've now constructed 3 lengths that can form a 3-dimensional rectangle, a shape that will enclose the distance from A to B. So that's it. Yeah, definitely tricky. The distance from A to B is going to be 10 squared plus 20 squared. I don't care which one's A, B, or C. It doesn't matter. Just the final answer, please, on this one. So, anybody have an answer on that? Yeah, I got the same, Shalon. So Shalon's answer is 26.9293 with Denny as well. That's very good. You can go to inches there, and you're going to get 26, I'll do it like this, 26.93 feet. So 26 feet, 11 inches. You can check that later. I showed you how to do feet to inches earlier today, so that's good to go. Whoops. See, it says here nearest inch, okay? Not quarter inch. Don't worry about that stuff. We already went through that whole discussion earlier. So anyway, there's a few questions involving the 3D Pythagorean theorem. It is possible to kind of work this question out by drawing a cube. I hope that drawing this cube is not going to waste a lot of time, so I'll just try to be very quick on the hustle here. Let's see if I can do that. So many of you can actually answer this question by just drawing a cube, and then in a way just taking that cube you can kind of see it there. Do you see what I'm doing with the cube? You can kind of fit a cube to the figure. I don't really like that approach, but you can do it that way. You can draw a cube on the figure. I'm going to leave the cube away from the figure because I do think it just confuses people. Yeah. The point that the cube makes, though, is that it is ultimately, all these three-dimensional questions can be modeled by that process. I don't know how many people actually deliver or explain the question this way, but I find that the simplest way to ask this question, especially with everyday life, is just to ask things like, I just ask questions like this, because these questions, most people can answer at least two of them without too much difficulty, and that was proven in the conversation. So we have time left. I'd like to spend the last 20 or so minutes maybe doing a few algebra questions. So let's take a look here at section 4.4, which is really just extra questions. So anyway, this question here is starting to get into a bit more complicated algebra. Has anybody tried this question already? Okay, so let's talk about this one. Once we do this question, the last two questions will follow very similar algebra. But this question is harder than the other two questions in a sense because there's no triangle that's obvious. You are going to be brave now, though. Who remembers chapter 1? Who remembers this theorem here? The tangent. Do you remember this rule? The radius and the tangent. Yes. So we have the radius here. That's the radius, just like this one. And that's a 90, let me say it clear, 90-degree angle. There's also another rule at play, which is this one here. Whoops. So there you go, my friends. We have a triangle, a right-angle triangle. Let's draw the triangle over here so it's nice and clean. Your goal here is to solve for r, so that's r. This is 13. Can someone give me an expression for the question mark? Yeah, it's because of the angle bisection. Yes, Denny. This angle gets cut in half. We're going to get into that conversation a lot in the next booklet in chapter 5 and chapter 6. This pops up again. So anybody can you give me an expression here? Okay, Shalon, I need to reprocess your statement there. I'm kind of reading it weirdly. Are you saying it makes it look easy, or you're saying the opposite? Oh, thank you. Sorry, because I was getting confused for a second. A lot of these questions, guys, it's all about pattern recognition. This is pattern recognition, I'm telling you. Once you see this question one time, if I go into another chapter, oh, why is it r plus 5? That's a good question. Let's answer that question. From here to here, let me highlight this in purple or something. Do we agree that this is 5? Are you good with 5 there, Denny? Is that 5? Okay. Yeah, okay. You figured it out now. I'm just going to finish it because there's other people in the audience that are probably questioning the same thing. This is r. The yellow part is r. So that's why it's r plus 5. Because we have another radius right there from here to here. So it's good that you brought it up so that we're all ready to go. So Now we're just going to use the Pythagorean theorem to solve for r. Unfortunately, we're going to get into some really crusty algebra here. So although I don't really think there's a question like this on your test, there's not really too much difficult algebra on your test. I might put a question like this or the next ones on your assignment. It could be an assignment question next week, just so you know. So really, I'm just preparing you for not next week's assignment. Sorry, the week after. Not next week. The week after, when you have an assignment. So r squared plus 13 squared equals r plus 5 squared. Let's talk about that statement. The longest side on this triangle is r plus 5, and that's the one that goes by itself. So from this point onward, we have an algebra question. This is no longer geometry, and yes, Maha, that is the right answer. I got the same as you. So I'm going to walk the class through it slowly because I know there's people here that are intimidated by this kind of thing. Don't worry, this is not going to hurt you for the test, but you do need to get better at this for later in the course. So r squared is just r squared. 13 squared is 169. This here, you're going to write down the r plus 5 twice, and you're going to expand it. Okay? And then from there, you're going to do the following. You're going to expand this out. So there's going to be 4 things to write down. I'll go through them systematically. First, you do r, FOIL. You do r times r, and you get r squared. And then you do r times 5 at the end, and you get 5r. Then you do 5 times r, and you still get 5r again. And finally, you get 5 times 5, which is 25. If you notice here, this r squared and this r squared, what happens to them? Yeah, they cancel out. And from there, we're good to go. So we have 169 minus 25, because I moved the 25 over, is 10r. I could write that as 10r. I could write that as 10r equals 144. And then r equals 14.40, because the question wants it to 2 decimal places. So it's 14.40 meters. Yeah, this question definitely is a bit more work, and it is on the tougher side for a couple of reasons. You got the picture to deal with, and some of the geometry that we talked about earlier with angles and with tangents and circles. And then you have the other avenue, which is taking this red triangle here and doing algebra. So I know there's probably some people in this audience. I'm confident, and I mean this kind of not in a negative way. I have a feeling that there's people that don't really understand what I did here. So if there's anybody here, these 3 steps here that I've highlighted in blue, if there's anybody here that's like kind of unsure about how you do that kind of thing, or maybe you haven't been in school for a while and you forget how to do that stuff, I'm going to share with you, and you can watch the video if you want to help you with that blue stuff. But it's basically me doing a bunch of questions like that and progressively getting harder. And math never hurt anybody, hopefully. So hopefully it doesn't hurt you too much to practice that. The difference between this question and the next question, in my honest opinion, I think the next question's easier. So let's take a look at it. That's the next question. And frankly, the next question here, 1 and 2, 2 is the same as question 1, except it's got some decimals happening, and there's an extra x down here. So what I'd like to do, there's an x right here. What I'd like to do is answer question 1 for sure, and if there's time remaining, I'll answer the second one as well. So let's go through this one. Do you see how this one is very similar to the previous example? It's very similar to the previous example. Okay, what is the longest side on this triangle? Let me know in the chat. What's the longest side on this triangle? Thank you, Denny. So we have x plus 7 squared equals the other ones, which are x squared and 12 squared. It's so close to the previous question. So close. So the left side, we're going to write it twice. And the right side, I'm going to just expand the 12 squared as 144. Over here, we have x plus 7. And again, x plus 7. Sorry, there's a little bit of a delay with my keyboard. There you go. So now we're going to take this thing here, and we're going to expand the x plus 7 times x plus 7. No, it's just the lines through the figure, Shalon, the lines through the figure is because these figures are coming from a scan. I scanned a document to get these, okay? So I really try to put together extra practice, extra help. Yeah, I know. I've tried my best to edit it out, but it's like I said, these are coming from extra documents that I had that have nice questions. So in this case, yeah, Denny, you are one step ahead of the step where I am, and I'll get to you in a second. But yeah, you're on point. So we're going to do expansion here of this binomial times this binomial. So x times x is x squared. X times 7 is 7x. Again, 7x. And then 7 times 7 is 49. The x squareds cancel. So you end up with 14x plus 49 equals 144. Thank you, Malik. So 14x equals 95. And if you do the division, I'm just going to work with thank you. So yeah, I got the same as you. I'm going to put an extra decimal if you don't mind, just because the question says 4 sig figs. So 6.786, in this case, meters. So to answer the question completely, because the question says find the 2 unknown side lengths. So we need this one and this one. So the first answer is 6.786. And the other one is 6 plus 7, so 13.79. So all I did there was I added 7. And why did I only put the 2 decimal places here? Because the question says 4 significant digits. So I had to remove one of those decimals. Okay, I'm going to do the next one. We have time for sure to do it. And then we can move on, and I'll let you go. I'll let you go after that. You can enjoy yourselves. I'll make an announcement on Blackboard, but you should be aware that next week, as we do have a test, whenever there's a test week, there's no class otherwise. So it's just the test. So I'm going to make the announcement again to remind you that there is no class on Tuesday. So there's just the test next week. If you have any questions, if you have any worries, if you're stuck on a question, if you're getting nervous about something and you need to talk to me or whatever, you are always welcome to find me. And the cheapest way, the quickest way is to go by email. So email me if you have anything that you need to talk about. Get on it by email. And I know, and you know me, people know me when they email me. I'm very good with my emails. Anyway, in this case, can someone tell me which of these 3 expressions is the longest side or represents the longest side on this triangle? Which of these 3 expressions is the long? Yes, thank you, Denny. So that's the one that goes by itself. So x plus 3.10 squared equals the other ones in terms of the Pythagorean theorem. Oops. This one here I actually wrote down on paper because I didn't want to waste time using my calculator or asking you with the calculator. So if you don't mind, I'm just going to go through this one a little bit more silent because it's just a lot of numbers on the calculator. Yeah, this is just all algebra, people, I'm telling you. That's why I recommend, if you have time, is to watch. I don't care about the video. I don't care if you watch the video. I'm just saying it might be valuable to you to watch the video to build up your algebra. That's all I'm saying. So I expanded the 4.21 to get 17.7241. I'm going to keep all the decimals as necessary because I suspect that it might come in handy later. When I'm done the question, I'll line up the equal signs. It's very annoying with the equation editor that I have to do that, but that's the way it's done here. So that's x squared, whoops, x squared plus 3.10x plus 3.10x plus 9.61. So that's all of this stuff. What I might do is just, I'll use some color, like a blue or something here, to just decorate it a little bit better. Just so you can keep track of which side is which. I know there's an equal sign, but that helps visually. And now we're going to do this brackets, binomial expansion. So 2.40 minus x times that again. So you're going to get 5.76 minus 2.40x minus 2.40x plus x squared. And from there, you can clean it up a little bit. So the x squareds cancel, and I think at that point you're in the home stretch for this question. I'm not going to line up the equal signs because now I'm crossing things out, so I changed my mind about that. That's okay. So we need to get the x's on one side. So we'll put 6.20x plus 4.80x equals the other stuff. So what I did was anything that was an x here, anything that had an x, any term that had an x, I brought it to this side. So this negative 4.80 became positive 4.80. These guys stayed the same. You see them, they're still the same there. But then this positive 9.61 went over here and became negative. And at that point, we're really close to the answer. We have 11x equals 1.261. Yeah, like terms on one side. Very good. For similar terms, if you prefer. So if we divide both sides by 11, you're going to get 1.261. Sorry. This is 13. I apologize. This is 13. Got a little ahead of myself. I was reading off my answer key for the last step there. Anyway, we have x equals 1.261 meters. And I'm just going to say here, just for the sake of, space, I guess, here, I can just say substitute. All right. Well, that's all I have for you today, everybody.